Okay, welcome all. So let us look into subtopic 4.2 regarding Newton's law of motion. So for this part, okay, I will go through with you regarding the problem solving. Okay, so let us look into first example. Okay, so which will be on example 2.1. Okay, so for example 2.1, okay, you have a load of 250 kg, okay, hung by a crane's cable, okay, and then the load is pulled by a horizontal force, okay, such that the cable makes a 30-degree angle to the vertical plane, okay. So that means you pull it until it makes an angle 30-degree to the vertical plane, okay. If the load is in equilibrium, okay, so they want you to calculate the magnitude of the tension in the cable, okay, magnitude of the horizontal force. Okay, now the keyword is that over here is that the load is in equilibrium. Okay, so if it is in equilibrium, so that means net force, okay, or total force will be equivalent to 0. Okay. Okay, now let us look into the solution over here. Okay, so this will be the situation lah. Okay, so this is the initial position over here. Okay, and then you provide a force. Okay, you pull it to your right. So whether your drawing is to your right or to your left, it depends lah. Okay, it can be either way. Okay, but in the end they will look at your calculation based on your drawing. Okay, so this one they are pulling it toward the right. Okay, so you have a displacement to the right. Okay, now if you draw a free body diagram, okay, this is how your free body diagram will look like lah. Okay, so the object, okay, use a dot to represent an object, okay, force acting toward right, okay, and then you will have weight acting downward, okay, to the center of the gravity, and then you will have tension, okay, tension acting over here. Okay, so if you resolve tension, then you will have x component, okay, resolve into y, and then you will have y component lah. Okay, so the angle, okay, so we can derive from the previous information. Okay, you displace by 30 degrees, so that means over here angle will be 30, and then here you will have 60 degrees. Okay, so once we have that, we can put it on the table lah. Okay, so weight only have y component, okay, which will be acting downward, so it will be negative mg. Okay, x component will be 0, so which you end up with 2453 Newton. Okay, and then for the force acting, okay, you only have force acting in x component only. Okay, y component will be 0. And whereas for the tension, okay, so since tension has angle, okay, you can resolve it into x and y component. Okay, so x component will be negative t cos 60 lah. Okay, y component will be t sin 60. Okay, since the load is in equilibrium, that means net force will be equivalent to 0. Okay, so that means when you add up all the x component, you should get 0, and then when you add up all the y component, you should get 0 over here. Okay, so this is the equation that you'll end up. Okay, so that means f minus, okay, tx component will be equivalent to 0, one equation. And then for y component, okay, t sin 60 minus with the weight lah. Okay, add up with the weight, minus, you will end up with 0. Okay, so you can solve it for y component first. Okay, sin 60 you can obtain the value, this one value weight already given, so you can determine the value of t. So once you have determined the value of t, you can replace back into equation 1 over here to determine the value of f. Okay, so which you end up with 1417 Newton. Okay, another second method is that by drawing a closed triangle. Okay, So basically previous one, okay, what we do is that we redraw a triangle, okay. So F in X component, okay, you have a T over here, and then weight acting downward, okay. So from the triangle, okay, cos 30, okay, so cos 30 will be equivalent to adjacent over hypotenuse. Adjacent will be the weight, okay, hypotenuse will be the tension, okay. Rearrange. So from here we can determine the value of T, tension, okay. Okay, and then for question B, okay, so to determine the value of F, okay, so also we use it from the triangle, okay, sin 30, sine opposite, okay, over hypotenuse, F over T, okay. So you solve it, you will obtain the value of F over here. Okay, now let us look into example 5. Okay, this one you have two objects, okay, masses M1 10 kg and M2 15 kg connected by a light string, okay, which passes over smooth pulley as shown in figure 4.11. Okay, so this one they wanted to calculate the acceleration of the object of mass 10 kg and the tension in each string. Okay, so the arrow over here shows the direction of motion, so the acceleration will be in the same direction. Okay, so that means M2 moving downward, it will pull M1 upward lah. Okay, so for solving, first thing what you need to do is that you need to draw a FBD, free body diagram. Okay, you need to separate lah, okay, M1 and M2. Okay, solution for M1. Okay, acceleration upward, okay, weight acting downward, tension upward. Okay, for this case, okay, net force, okay, or total force will be equivalent to MA. Okay, so since we are referring to object 1, so that means the net force, okay, for the net force we will follow the direction of acceleration. So acceleration moving upward, that means T1 will be positive. Okay, so that means T1 minus with W1 will be equivalent to M1A. Okay, so if you expand this one, you will end up with M1G lah. Okay, the weight over here will be equivalent to M1G. Okay. Okay, where the tension, okay, since it is attached in the same system, tension T1 and T2 will be equal lah. Okay. Okay, so expand, replace in the value, so you will end up with T minus 10G minus 10A. Okay, equation 1. Alright, for the second object, okay, 15 kg, acceleration moving downward, okay, tension upward. Okay, now for this case, okay, so net force, total force will be equivalent to MA. Okay, since acceleration is moving downward, okay, over here downward, so that means W2, okay, the weight will be in the same direction as acceleration, so that means weight will be positive. So the equation will become as W2 minus T2 will be equivalent to MA. Okay, so since over here we are referring to object 2, okay, W2, that means mass 2, G, okay, tension 2, so the mass will be the mass of the object, okay, which will be M2. So replace in the value, okay, so rearrange, you will end up with equation 2. Okay, so since now you have two equations, you can solve it simultaneously. Okay, so over here they use addition lah. Okay, equation 1 add up with equation 2. Okay, so solve it to obtain the value of A, acceleration. Okay, so once we have the value of acceleration, we substitute, okay, into equation 1. Okay, either one equation lah, or 1 or 2, to obtain the value of the T, tension. Okay, alright. So that's all for this 2 example. Okay, have a nice day. Okay.